So the laws of exponents can look quite confusing when you're just given a list and all it is letters. I'm going to show you how to put the laws into use with numbers. So step number one on this first one is whenever you have an exponent outside the bracket and exponents inside the bracket, the rule is to multiply those exponents together. So when you have a power of a power, you multiply. And we can only do this because there's no adding or subtracting inside the brackets. So for the first one, I'm going to end up with x to the exponent -9 and y to the exponent +9. It's really important that you keep your exponents looking like exponents, so they're superscript, meaning a little bit smaller and raised up. So now that -3 is gone because I've distributed in by multiplying. Now for the second bracket, I'm going to do the same thing, and I'm going to remember that whenever you don't see an exponent, there is an exponent 1 there. I'm going to multiply all these exponents by 2 because an exponent outside the bracket goes and multiplies all the exponents inside a bracket as long as there's no adding or subtracting inside that bracket. So I did 2 times 2, 1 times 2, 1 times 2, and 2 times 2. Now I'm going to clean up inside the bracket. I can't do anything to the first bracket because I have different bases. One is an x and one is a y. But inside the second bracket, I have a division. I have x's on tops and y's on the bottom. X's and y's both on the top and x's and y's both on the bottom. So this is dividing. And when you divide powers, the rule is subtract the exponents. So I'm going to end up with x to the 2, 4 subtract 2, and y to the -2, 2 subtract 4. Always subtract from top to bottom or in the order of the division. Now, when brackets are touching, the operation is multiply. And the rule for multiplication when you're dealing with powers is you add the exponents. And I can only put like bases together. So this x is going to go with this x, and this y is going to go with this y, and I'm going to write them with one base and one exponent. -9 plus 2 is -7, and I put those two together because they are the x's. 9 plus -2 is +7. So now that is a right answer. However, sometimes you will see that they say write your answer with positive exponents only. A negative exponent really means a division. So instead of writing this as x to the -7, I can write it as divided by x to the 7 because this isn't really -7. The negative means divide and our exponent is 7. But again, if they don't say that you must have positive exponents, you could leave your answer as that step. Now, some people say, well, wait a minute. Why wouldn't I clean this bracket up first? And I'm going to show you that you would get the same answer. So I'm just going to repeat the question and say, in BEDMAS, brackets come first. So if there are things to do inside the bracket, you have to do them first, according to BEDMAS. Nothing to do inside this bracket because it's an x and a y and they can't go together. So it's going to stay the same. But in the second bracket, I'm going to leave the exponent 2 outside because that is the second step for BEDMAS. I'm dealing with the first one, and I'm going to do this division. 2 subtract 1 is 1. 1 subtract 2 is -1. Now I'll deal with the exponents by sending them in and multiplying. So then I get x to the -9, y to the +9. I multiplied the 3 in. X to the 2, y to the -2. I multiplied the 2 in, which gives me my same answer. X to the -7, y to the 7. So you can deal with outside exponents first, then deal with it, or you can deal with inside the brackets. Okay, so this one is a little bit confusing because I have a lot going on. The thing I want to be careful with is I cannot distribute this -1 into the bracket because there is a subtract there. You can only distribute an exponent into the bracket when there's no subtract. This one I can though. I'm going to distribute the -1 with that exponent in the 2 on the bottom because that way I'm not going around the subtract, and this quantity is all in a bracket. So I'm going to end up with x to the negative 1 minus y to the positive 1. Negative 1 times negative 1 is positive 1 over x to the negative 1, y to the positive 1. So now that's going to equal x to the negative 1 minus y. I don't need that exponent 1 because 1 just means one bracket, over, have x to the negative 1 on the bottom that I want to deal with. Negative means divide it by. So if I'm dividing by 1 over x, this is the first dividing. Divide it by x to the negative 1. X to the negative 1 is 1 divided by x again. That becomes multiply by x over 1. It really just moves the x to the top. I teach my students that negative exponents are like elevators. If it's a negative exponent on the top floor, it moves to the bottom floor and your exponent is no longer negative. The opposite of that is if it's a negative power or negative exponent on the bottom floor, it moves to the top floor and becomes positive. So the x is going to move to the top floor and this negative 1 will become positive 1. Now I'm going to send that x into the bracket. So when I multiply x1 times x to the negative 1, I add those exponents and I get 0. X times y is just xy. Any base to the exponent 0 is always 1. That's another law of exponents. So my final answer for this isn't really pretty, but it's 1 minus xy over y. This one we're actually going to calculate. And there's a couple ways to deal with the 2/5 when I send it to the number. 32 to the 2/5 means the fifth root of 32 squared. Now I know that the fifth root of 32 is 2 because 1, 2, 3, 4, 5 2's would equal 32. You could get that out of your calculator by using, you should have like an any root button that looks like that, or you could do 32 to the exponent 1 divided by 5 because the bottom number gives you a root. So that only deals with the 5. I still have the squared and I get 4. If you know how to work your calculator though and you type in 32 to the exponent 2 divided by 5 or 2 over 5, if you have a fraction key, it should tell you that the answer is 4. So when I have a number and I distribute the power in, I actually calculate it, whether it's with my head, the fifth root of 32 is 2, 2 squared is 4, or with my calculator. But when it comes to letters, it's a little bit harder because I don't know what x is, so I can't type it into my calculator. But just like before, when you have a power inside a bracket and one outside a bracket, and there's no adding and subtracting, you multiply. So we need to do 15 times 2 over 5. Whoops, I'm thinking of the answer, 30 over 5, which gives me 6, because 15 is really 15 over 1. To multiply fractions, you go across the top, across the bottom, then that division works. So I'm going to end up with x to the exponent 6. Another way to do that is to say 5 goes into itself once, into 15 3 times 2 equals 6. I'm going to multiply 5 times 2/5 to get my exponent on the y, because again I multiply those together. So you could go 10 over 5, which gives you 2. Or you could go times 5, divide it by 5. It goes into itself once and once. I don't need to do it. And so my final answer is 2. So 32 x to the 15th, y to the 5th, all to the exponent 2/5 ends up being a fairly nice answer. 4 x to the 6 y squared. And now finally we're going to deal with some roots. And I'm going to think about it, the numbers and the letters. So now they want the fourth root of 16. I can calculate that in my calculator, or I know it's 2 because 2 times 2 times 2 equals 16. So then the answer is 2. Now I need the fourth root of x to the 8th, which is a little bit more complicated because I can't type it into my calculator. But roots are the same as fractional exponents. So instead of having fourth root, I can think about it as to the exponent 1 over 4. I multiply those together. 8 times 1 is 8. 1 times 4 is 4. which actually works out to x squared, 8 divided by 4. Because whenever you have a root, you can just divide exponents. So I can work it out the long way, but I know that my exponent on the y is going to be 3. 12 divided by 4. On the bottom, I have to deal with this cubed first, so I'm not dealing with this root yet. And when there's no number there, we understand it to be a square root. Mathematicians are lazy. This is the most common, so they're saying, why do we have to write the 2 all the time? If there's no number there, we understand that it's square root. 4 cubed is 64. 4 times 4 times 4. I'm going to get x to the 12. 4 times 3. Y to the 6, 2 times 3. The square root of 64. Keep my top, almost forgot about that. The square root of 64 is 8. The square root of x to the 12 is just 12 divided by 2, so x to the 6. And the square root of y to the 6 is going to be y to the 3, 6 divided by 2. Now I can't do 2 divided by 8, but I can reduce it into lowest terms. 2 divided by 8 reduces to 1/4. The y's will cancel out or give me y to the 0, which I'll clean up in a minute. When I do the division for my x's, 2 minus 6 is -4. So then my final answer with positive exponents is 1 stays on top, 4 stays on the bottom, but this is a negative power, so this negative is my elevator. X to the 4 is going to move to the bottom floor and become positive, and any base, even letters, to the exponent 0 is 1, so I don't need the y to the 0.